Hello and welcome back. In today's session, we are going to take a look at logical operators. Under logical operators, we have three operators: AND, OR, and NOT operator. Let us take a look at these operators. Let's open up PyCharm. Let me comment out the earlier code. Okay, so let us look at logical operators. And we have AND, OR, and NOT operators. With logical operators, you can evaluate Boolean values. Boolean values will contain, or bool values will contain true or false. For example, if I define variable 1 as true and variable 2 as false, then print of v1 and v2. So we are using logical operator AND here, and print v1 or v2. NOT operator works with only one operand, that is one variable. So let us see. So NOT of v1. So we can also use, for example, NOT of v1 or v2. So here first it will evaluate v1 or v2, and then it will invert the value which is provided by v1 or v2 evaluation. Okay, so let me execute this. So v1 and v2. So v1 is set to true and v2 is set to false. For AND operation, if both are true, then the result will be true. If one of them is false, then the result will be false. For AND operation, the result will be true only if and only if both v1 and v2 are true. However, with OR operation, if any of the variable is true, or if either v1 or v2 is true, then the result will be true. Okay, so that is why we can say since v1 is true and v2 is false, we see the result as false. In case of OR operation, since one of them is true, that is v1 is true here and v2 is false, even though v2 is false, v1 is true, the result will be true in case of OR operation. So in case of not v1, so since v1 is true, not will make it as false. So not v1 is false. And in case of the last print, so v1 or v2, which is this true value, and it negates that value and makes it as false. So that is why we see false here. Okay, so let us change v2 to true. And re-execute this. Okay, now V1 and V2 is true because both of them are true. As it says here, if both are true, then the result will be true. That is why we see true here. Okay, so or if any of the variable is true, so here both of them are true, then the result will be true. Okay, so not V1 as earlier, so it is false, and V1 or V2 is true, and not of V1 or V2 is false. So this is nothing but logical operators. Okay, so let us take a look at bitwise operator. Under bitwise operators we have AND, OR, ones complement, XOR, left shift and right shift. Bitwise operator works with binary data. The value assigned to a particular variable or the value itself is converted into binary value, and then these operations are performed on the binary data. Okay, so let us see an example of these. Let us open up PyCharm again and let us add bitwise operator 1 is equal to let's say 6, BO2 is equal to suppose say 7. So 6 in binary is written as 0 1 1 0. So this last 0 is 2 to the power of 0, 2 to the power of 1 and 2 to the power of 2. So 2 to the power of 2 is 4, 4 plus 2 is 6. So in case of 7, so this is written in binary as 0 1 1 1. So 6 plus 1 is 2 to the power of 0 is 1. So 2 to the power of 2 is 4 and 2 to the power of 1 is 2. 4 plus 2 plus 1, which is 7. Okay, now print BO1 ampersand BO2. Similarly, print BO1 or BO2. So this has to be BO2. Print ones complement of BO1, and we will also print BO1 XOR BO2. And finally, we will look at shift operators. BO1 left shift by 2 and print BO2 right shift by 2. So let us execute this. Let me comment out this part and execute only bitwise operations. Okay, as I said earlier, bitwise operator works with binary data. So this is the binary data for this value BO1, which is 6, and this is the binary data for BO2, which is 7. Now BO1 and BO2, so that is AND operator. Remember the AND operator earlier. So only when it is 1 we get the result as 1. So in both cases BO1 and BO2, there are 1 at 2 places, that is second and third place. So this will result into 0110, which is same as this, and the result value is 6. As I said earlier, in case of OR, if one of them is true, so in this case true can be considered as 1 and false can be considered as 0. So here it is true and this is false. So whenever we use OR operator between BO1 and BO2, wherever there is 1, the result will be 1. So in case of 6 we have 2 ones, and in case of 7 we have 3 ones. So the result will be 3 ones. That is why we get the result as 7. So the ones complement is giving us the result as -7. The formula which is used with ones complement is minus BO1 minus 1. So BO1 is 6 and it is -6 minus 1. So this will become -7. In case of XOR, BO1 XOR BO2. So in case of XOR, what happens is wherever there is a 0 and 1, so that will become 1, and wherever there is 1 and 1, so that will become 0. So the result will be, so 0 and 0 will be 0, and 1 plus 0 and 0 will be 0, 1 and 1 will be 0, and 1 and 1 will be 0, and 0 and 1 will be 1. So wherever there is a 1 and 0, only those will be 1. So this will be the result. So this is nothing but value 1. Now in case of BO1, left shift twice. So if we represent BO1 in 8 bits, then this will become 0 0 0 0 and 0 1 1 0. So this is how it is in byte. Byte contains 8 bit. So in case of left shift, so here we are shifting the value by 2. So these two 0 will go and there will be 2 zeros added at the front. So this will become, the result will become 0 0 0 1 1 0, and there will be 0 0 added at the end. So this is still 8 bits. So now if you look at this, so this is 2 to the power of 0, and this is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. So 2 to the power of 4, which is 16, and 2 to the power of 3 is 8. So this location of 1 1, which is at 2 to the power of 3 and 2 to the power of 4, so which yields 16 and 8. So if we add them together, so that will give us 24. So that is what we got here as a result. So in case of right shift, what happens is the initial value is 0 0 0 0 and 0 1 1 1. Okay. Now the result will be, we are shifting now right. So these two will be removed from the front and there will be zeros added at the back. So the result will be 0 0 0 0 and then 0 0 0 1. Okay, which will be 2 to the power of 0, which is 1. So that is why we got 1 here. So if I remove this and then shift it 3 times, then let us see what happens. Now we got 48 and then 0, because when we shift it 3 times this 1 is also gone, so that is why we get 0 here, and this will get shifted by one more place, so 2 to the power of 5 plus 2 to the power of 4, so that becomes 48. So there is a method called binary if you want to print the value of any number, for example 6, so that will give you 0b110, that is nothing but this value here. In today's session we have covered both logical operator and bitwise operator. So bitwise operator works with binary data, wherein the logical operator works with the Boolean values.